This video is to accompany the OneNote I have created for the submission on deliverable 2 of the final year project. My student number is G207065668. The question and working title for this project is a Raspberry Pi a suitable medium for home automation? The way I've set out about answering this question is through a Moscow analysis. I'll go through each of these as they've been specified in the accompanying OneNote. The first section would be the musts, the first one is a Pi should be security hardened against potential vulnerabilities. I've got a full list of these in the OneNote. I can go on to specify these because some of the should and could requirements do specify a certain wave of penetration testing that needs to be done in security hardening. So the next requirement on the must is the Pi must host a web page displaying the GUI service for users that is functional. So I'll just demonstrate this on a mobile device. I go in here. If I'll access the local address, which is 192.168.1.152, then I can access my GUI. If I click on, that's my home page as a proof of concept, then go on lights. I've actually got my system over here, so if I press on here, then it works. And if I press off there, and then I've got an alarm, and if I press on here, the alarm sounds on, and press that and it turns off. I'm just going to leave that on. So that's the GUI working on the local address. I'll go on to talk about the public address and talking about dynamic DNS and port forwarding later on. The next requirement in the must is the Pi must control an appliance through a relay board. For example, a light. What I've done here is I have my lamp and the cable that's running through it. It's all jumbled up here, but basically this is my relay board. I've actually cut the flex in half. I've described all this in my OneNote entries, peeled back the flex, crimped the two blue wires back together, and then these two brown wires going into the switch, which basically makes and breaks the circuit. I've documented that the circuit actually works, and then this is actually controlled through jumper cables by a Raspberry Pi, and then this is connected to the router, and then we access that through the mobile devices or any device that you want to control the Pi. We also have got the alarm there as well. The next requirement is that security hardening is done on build to protect against vulnerabilities done in test 1. Test 1 defines the first wave of security hardening, some of which has been specified by my tutor. This is all outlined in the OneNote, but I'll read them out quickly. So we've got change the password on the Pi user. This was changed to a secure password pretty much straight away, just to avoid anybody who knows the default password on a Raspberry Pi is Raspberry from just logging into the Pi and then doing anything with the system. Also, add a new user with a secure password. All of this is detailed in the OneNote, but I added a user called tbowker1 with a secure password on there. And then the next bit of security hardening was make any sudo commands require the password anyway, just to make it even harder for anybody else to do anything. The next one was to ensure I have the latest security fixes. So that is to just make sure that the SSH server is up to date. The next one would be to deny the Pi user from being accessed with SSH. And then I would demonstrate that now, but the next one in the list is actually deleting the Pi user after making a couple of backups, which is what I have done. So if I go into PuTTY and just use the local address now to access it, 192.168.1.152, and go into SSH and I'll log in here. If you even try to attempt the Pi user and any password, so just do the password that I did before, deleted the user, then it should come up with, access denied. That's because the Pi user doesn't exist anymore. So we'd have to go out of the PuTTY session. If we go back into it and try and access through the local address again, and we access through the new user, which is tbowker1 with the secure password. Gonna have to try that again. Try the secure password. And then it's a successful login. If I just do an if config, just to see, check what the local address is there. You can see 192.168.1.152. We needed this to get onto the PuTTY session, but that is just saying there. If I just do a quick who am I command, then it'll specify the user. And the Pi users directories have stayed there, seeing as I did most of my work up until that point on the Pi user. Even though I deleted the user, the directories did stay there. The next thing in the security hardening was to set up a firewall. I used just the default uncomplicated firewall and which actually stopped everything from working because it just blocked everything. So then I did a Wireshark packet capture, and needed to first of all allow SSH packets through. Knew that straight away without the packet capture, just so I could access it from a remote terminal. And then after setting up the GUI and so it could be accessed from a remote device, I could let through HTTP packets. These are the only two exceptions to the firewall. The firewall does block pretty much everything else. And then obviously the next thing was delete the Pi user after making backups. One of the things that was specified to me by my tutor was to install an IDS system, intrusion detection system. The first one was Bro. I had some trouble installing this, but this could be something that could be worked on for the second wave of security hardening. Okay, so if we go back to the Moscow analysis, going back, so the must requirements have been done. The Pi should be security hardened against potential vulnerabilities. That's definitely covered. Security hardening done on build to protect it against the vulnerabilities discovered in test 1. That's done. Control and appliance through the relay board. That's done. Pi must host a web page displaying a GUI service for the users that is functional, and we can see that in the video as well. Moving on to the should requirements, the security hardening to protect against at least one of the vulnerabilities discovered in test 2. Actually, because this is the first time I've done the project, the testing phases kind of melded into one, and after I could work on, I had trouble ordering some equipment and ordering backup SD cards, so it actually took up a lot of time. So what I'm going to do is mention in the dissertation any other potential vulnerabilities that I find. Currently, if I go into Nmap and do a intense scan on the Raspberry Pi, it's actually showing that the only ports that are open here are the 22 for OpenSSH and the 80 to let HTTP packets through, because the Pi is running an Apache server to run the GUI on. A copy of the Nmap that I've done is available upon request, and a screenshot of it is also in the OneNote. The next one for the should requirements is the GUI should work on multiple types of devices, a laptop, a phone, or an Android, etc. So I've got screenshots of the system working on an Android phone, and I'll also just demonstrate that it works on the laptop. There you go, that's the system there, and it does. Well, that's just because I've disconnected from the internet on here. Just connect that. Okay, the internet's working, and if I click this button on here, then the light should turn off and on with the alarm here as well. So the GUI does work. The next part of the security hardening would be accessible by multiple users. Anybody over the age of 40 has diminished eyesight, has been mentioned to me by my tutor to some degree. This was something I haven't actually gotten to do any user testing as of yet because I've run out of time. So the time management is something that I definitely want to work on in the future. Any sort of user testing now wouldn't actually change anything about the project. It would just be users actually using the system and commenting on the appearance and how easy it is to use and stuff like that. I'd definitely, in the future, I'd include maybe a zoom in button or some more appealing colours that would be a lot easier to read for somebody who's maybe a bit impaired with their sight. If we move on to the CUD requirements, control more appliances, 2 or 3. I already control 2 appliances there, so at least it's more than one. It's a proof of concept that basically we could potentially use this for a house, a full house system, so to control heating, cameras, alarms, just like I've got here, or we could use it for a small business or for the elderly or disabled to allow them to live more independently. There's multiple applications for this type of system. The next thing would be to security harden to protect against all the vulnerabilities found in T1 in test 1s and 2. Apart from the IDS system, Nmap hasn't found anything thus far, but I will continue to try and find any more vulnerabilities and protect against those in the future. But as for this deliverable, apart from the intrusion detection system, I think I've pretty much protected it as well as I can. The GUI conforms to HCI design principles is the next point on the CUD requirements. What I've got here are some golden rules of interface design by Schneiderman, which is Ben Schneiderman, who's a computer scientist. A bunch of those are listed in the OneNote that I've basically made the GUI to be functional and haven't really worked on the HCI principles, but there will be some more mock-up designs made that will be included in the dissertation in part of the literature review. The next point would be to control the Pi through the internet. So this would basically serve as if you're a small business owner and you wanted to turn all your lights on and off, or turn the alarm on. If you saw somebody on your cameras breaking into your office, this is so I can demonstrate this. If we turn the Wi-Fi settings off on my phone, so I'm just on a 4G network, and then access, so this is the local address here, that's just hasn't been refreshed. What I can do actually is go, so the public address actually changes all the time, so this is something that somebody wouldn't want to do all the time. So what I've done is I've set up a dynamic DNS domain name here. So if we just do pi home.hop2.org, this actually goes straight here, so you can access this from anywhere. I've actually had this tested from going into the CM120 in University of Central Lancashire, and access this from home, having been on the phone with somebody else, and actually worked from a distance. So that's still working there, and the light still works as well. Off and on again. Okay, and then back to the home page, just saying it's a proof of concept system. The next part of the Moscow analysis would be, so basically the could and would requirements are things that I would like to do. Some of them, if I could get them done in time for the project deliverable, then great. If not, this is stuff that I either didn't have the time or money but would still like to achieve in the future. So the first one of these is control 7 or 8 appliances, and this also links in with point 4 on the would/won't section, which is maybe have a network of Pis with a central server. This could also be a Raspberry Pi as well, which is dedicating a Pi to each system in a household or business. So for example, having one Raspberry Pi to control the lights on multiple floors of a building, having another Pi to control the heating. This would take away a lot of processing power from just having one Pi. Also, this helps with any sort of like cabling issues and stuff like that. The next one would be test with a wider variety of devices such as a sound system, etc. This would be really good if you could just control every aspect of your house, any aspect that a client would need if this turned into a product for a business that could be sold. The next point is have a range of protection methods in place to protect against potential vulnerabilities. So obviously this is devoting a lot more time and money and research into maybe some sort of intrusion detection system that I could pay for. Obviously this is outside the scope of my project, so I haven't done that as of yet, but this is something that could be done in the future. The next one, a native application to control network, to control the network, like an app on your phone that still uses the internet. Obviously this is a commercial type of thing. The closest thing I've got to this is creating a shortcut on my mobile phone's home screen. You just click on that. I've renamed it and it takes us straight there. That's actually a local address from my home address, but obviously the local address has changed now that I'm in a different location demonstrating the project here. You can just save it to any address. The next point would be speech recognition software. So this would be basically having microphones in place, or having maybe a Pi with an attachment on in every sort of room in your house or in doorways or anything like that, and you would just tell the system what to do, and then that would filter through into any other Pis in the household or business, and it would conduct the task that you specify. Okay. So that is it there. We've demonstrated the local address and the dynamic DNS host there. Okay. Last thing would be just to detail the actual build of the project. So we've got the lamp here. So we've got this plugged into an extension lead because I've been advised by my tutors that working directly with mains is obviously unsafe. So I've put in an extra sort of extension here, which means basically the fuse in the extension lead and the fuses in the plug for the lamp is protecting the system from blowing up, because it's the first time I've done it. I'm a little bit new to it, so I wouldn't be sure what could happen. So I'm just doing any sort of precautions that way. This cable goes all the way around and through, and like I mentioned before, has been cut in half and put through the relay board. This acts as a switch to make or break the circuit. These 3 jumper cables are going straight to the GPIO pins on the Pi. These are specified in the OneNote which ones are going to what device. Some other GPIO pins are going to the alarm system as well. They're specified in the OneNote also. Then the rest of this cable that comes out of the relay board on module 1 is going into the lamp, which is then being controlled. This is basically making or breaking the circuit. The Raspberry Pi is using an Ethernet cable that's going straight into the back of the router, providing the internet, obviously NATing out to from the local address to create a public address, which we're then doing port forwarding on, which is also detailed in the OneNote. Obviously just got a power cable and a HDMI there if needed, if I needed to go onto the actual GUI to do anything extra. Okay, I think that's pretty much it.